All right, so we're going to talk about right triangle trig today and tomorrow, okay? And then I'll give you a practice quiz over this on Friday. We'll go over it next Monday, and your last quiz, AJ, will be next Tuesday. Okay, then we'll do exam review, correct? All right, so you're going to figure out the 6 trig functions today. All right, and you're going to use trig functions to find lengths of right triangles, okay? So it's really pretty easy. So let's get into it right away. The 6 trigonometric functions are, it says, consider the right triangle here on the right. And we call this blue circle with a line through it, we call that theta. It's a Greek symbol, okay? So to represent an angle, they use that symbol theta, okay? So if this is theta here, this is the opposite side, the one straight across from it. This is the adjacent side, the one that's touching it, and not the hypotenuse, because both angles touch the hypotenuse, right? The hypotenuse is the one that's opposite the right angle always. It's that longest side of the triangle. They call these the legs usually, and it's a right triangle. The 2 legs and the hypotenuse. Okay? It says ratios of a right triangle side length are used to define the 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. And it says these 6 functions are abbreviated as SIN for sine, COS for cosine, TAN for tangent, CSC for cosecant, SEC for secant, and COT for cotangent. So those are the 6 trig functions or trig ratios. Okay? So we're going to write those as fractions. All right? So here are the 6 trig functions. The sine of theta is the opposite side length over the hypotenuse length. Okay? Like 3 over 5 or something like that. It'd be that fraction. Okay? Cosine is the adjacent side length over the hypotenuse, and tangent is opposite over adjacent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay? So they use abbreviations OPP, ADJ, and HYP for those 3 sides. And since those are reciprocals, you could also think of cosecant as 1 over the sine, secant as 1 over the cosine, and cotangent as 1 over the tangent. You can think about it that way as well. But we usually just flip the fractions. But remember, whenever you write fractions, they must be in lowest terms. So if you have, a 6/10 as a sine, you should reduce it to 3/5, right? If you have a 2/4 as a cosine, you should reduce it to 1/2, right? All right, the way I remember it is this. So, ka, toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's how I've always remembered it. So, ka, toa. All right. So again, this should be review for you guys from an earlier math class you had. Okay? You good? AJ, you ready?
Oh, I have a ready?
It's just trigonometry class, not geometry.
Well, this feels like.
All right, so here's a right triangle. We're supposed to evaluate all 6 functions. In order to do this, we need to know all 3 sides. How do I find that hypotenuse?
Pythagorean theorem.
Vincent, you are correct.
Hey, good show. A squared, B squared, C squared. So 25, 144.
I use that in my everyday life.
Oh my God.
Okay? These are the 2 legs. I don't care which one you make, but you can label it as, we label this A, B, C. Okay, the hypotenuse is always side C. So we label angles with capital letters, and we label sides with the lowercase letters. So if angle A is up here where theta is, the 12 is my side A. If angle B is down here, lower right, like we have it, then my side B is the 5. C is always the hypotenuse. Okay? So, to figure this out, we would go A squared plus B squared equals C squared. So that's 144 plus 25, which is 169, and that's a perfect square. What's the square root of 169? Right, 13.
How'd you know?
So, remember, to finish, you got to take the square root. So now, we have our 3 side lengths. Okay? So, if you remember this, you should be able to get the first 3, and then all you have to do to get the other 3 is do what with those fractions? Reciprocal, right? So, the sine of theta is opposite, here's theta, opposite 12 over hypotenuse 13. You guys with me on that?
Yeah.
What?
Here's theta,
Okay, yeah.
so opposite's 12,
Yes.
hypotenuse is 13.
Oh, okay.
So I thought.
Opposite over hypotenuse.
I thought it was always the opposite of the hypotenuse.
It is. So here's theta right here.
What's theta?
That's the angle they're telling you to figure out.
Oh, okay.
So opposite of that is this side, right? Straight across.
Okay.
Hypotenuse is always the one opposite the right angle.
Oh, okay.
Okay? What's the reciprocal of sine? Cosecant. So what's that answer? 13/12. Just flip it. All right, cosine of theta. All right, ca is adjacent over hypotenuse. So here's theta, adjacent's the 5, hypotenuse is the 13. Its reciprocal is secant. So we write 13/5. Okay. And again, tangent, TOA, opposite 12 over adjacent 5. So cotangent is its reciprocal. So that'd be 5 over 12. So there's our 6 trig functions or trig ratios.
1, 2, 3.
All right, so the first thing we had to do is find the hypotenuse using the Pythagorean theorem. Okay? You have to know all 3 sides before you can do that. Caleb, quit texting her in class.
Oh.
Your phones are supposed to be away. All right?
We might need some beer.
That's chocolate milk.
It's not.
We have to find all of them.
Yeah, we have to find all of them for every problem.
When it says 6, yeah.
Awesome. But there's only.
Ah, cool.
1, 2, 3, 4, 5, 6.
Are they just reciprocals?
Yeah, oh my god.
Yeah.
Oh my god. Find the
Yes.
first three and then.
Sorry, Caleb was distracting me.
Yeah, I know he is. He's been very distracted lately.
Excuse me.
Okay, any other questions?
I'm gonna point my finger up.
20.
It is up in the air.
Okay, so looking at theta, which side is the 10? Opposite, adjacent, or hypotenuse? Adjacent, right? Looking at the 18, opposite or hypotenuse? Hypotenuse, okay? So, again, it doesn't matter which one A or B is, but C's got to be which one?
18.
Right, the one opposite the right angle. So angle C is always the right angle, all right? A and B doesn't matter, all right? But you should probably label that so you know which one's which, okay? So that means we're looking for side B, right? Correct?
Yeah.
Yes.
Okay. So A squared plus B squared equals C squared. Okay? So we got 100, and I think that's 324. Somebody check me. 18 squared, 324? Broad? Oh, Taylor, you got me? All right, thanks. So what am I gonna do with the 100 now? Subtract it, which is 224.
Yes.
Now, 224 is not a perfect square. So what we're going to do is put it in simplest radical form. We're not going to put the decimal, what is it, 14.9 or something? All right? So when we take the square root, we're going to do our factor tree and put it in simplest radical form. So I know 4 should go into it. So what's 4 into 20 would be 5. 4 into 20, 56. So there, well, I just circle the 4 because I know 4 is a what? Perfect square, right? That's what we've done in the past, right? And what's this? 8 times 7?
Yep.
And 4 times 2? So there's another perfect square, right? So since there's 2 4s, I can pull out what? A 4, right?
Yeah.
Or you pull out a 2 for each one, and what's 2 times 2? 4, right? What's left? 7 times 2? 14. So that's what we're going to use for side B. You with me?
Yeah.
So simplifying the radicals, nothing new. You guys should know how to do that, right? Okay. So finding all 6 then. All right. Let's see if I can move this all together so we've got room. All right. We'll just move this down here. If you need to see the work still. All right. So we're going to do sine and then cosecant. Those are the ones that go together. Cosine and secant, and then tangent and cotangent. So there's our 6 answers we're looking for, right? All right. So sine of theta, and theta's over here, is opposite over hypotenuse. So 4 radical 14 over 18. Can I simplify that fraction? Is there a number that goes into 4 and 18? 2. So it's 2 radical 14 over 9. Okay? So, when I do cosecant, what's that look like?
It's opposite. It's 9/2 radical 14.
Correct. Can I leave my answer like that? No. So what do I gotta do with that radical?
No. Square it.
How do I get rid of the radical in the denominator? It's called rationalize the denominator.
Move it.
Say that again? No, you're close.
Multiply by itself. Multiply the radical.
Yeah, the radical 14, you want to get rid of that radical, right? So that's what you're going to multiply top and bottom by. All right? So the top becomes 9 radical 14. What's the bottom? What happens when you go radical 14 times radical 14? What do you get?
Nothing.
What's it? What do you mean by cancels out?
The number should turn into itself.
Turns into itself, right? Radical 14 times radical 14 is 14. But what else is there? 2. So what's 2 times 14? 28. Okay? So 2 times radical 14 times radical 14 turns into 28. Okay?
Yeah.
Cosine. Adjacent. 10 over hypotenuse. 18. Does that reduce? To what? 5 over 9. Good. So what's secant? 9 over 5. Tangent. Opposite over adjacent. 4 radical 14 over 10, right? Does that reduce? To what? 2 radical 14 over 5. What's cotangent going to be then?
5/2.
Right. So it's 5 over 2 radical 14. So we got to do that same thing, right? What'd you guys tell me the bottom was? 28. Okay? Questions? Not yet, EJ. We understand how to find sine, cosine, tangent, cosecant, secant, cotangent. Got to use Pythagorean theorem to find the missing side, right? Remember, the right angle is always C, so the hypotenuse is always side C, right? Capital letters for the angles, lowercase letters for the sides. Okay? All right. Here's another type of problem. It says in a right triangle, theta is an acute angle and sine of theta is 4/7. Okay? So draw a picture of a right triangle. Let me do a nice one for you. All right. So here's our right angle. You can put theta wherever you want. I usually put it down here, but it doesn't matter. You can put it up there. Okay? So sine is opposite over hypotenuse. So which side's opposite of that? This one, right? Which side's the hypotenuse? So there's where the 4 and the 7 are. Okay? So now it's a problem just like we just did, right? What do I have to figure out? The adjacent side, correct. So how am I going to do that? Right. So 4 squared, we'll just call it b squared. We'll make this b. All right. C, we'll call that one a. All right. Equals 7 squared. You guys with me?
Yeah.
So you got 16 and 49 What am I gonna do with that 16? Subtract. So what's 49 minus 16? 33. So what's B?
Kinda quiet.
Square root of 33. That won't simplify, will it? It's just 3 times 11, right?
It went away. It's small.
Okay?
It's tiny.
Quit doing your mumbling and screwing around. Pay attention, please. Any questions on how we got square root of 33?
No.
No. All right, so we already have sine was what? What did it tell us? 4 over 7. So I already have cosecant, which is 7 over 4. All right, let's do cosine. Adjacent is radical 33 over hypotenuse 7, right? So secant is 7 over, which
Oh, that can't happen.
we can't have it stay like that. So it's 7 times the square root of 33 over 33. And then tangent is opposite 4 over adjacent square root of 33. So cotangent, oh, I gotta finish that, don't I?
That can't.
That can't happen, right?
Not real.
So it's 4
33.
radical 33 over 33. What's cotangent? Just flip the original.
The reciprocal.
Yeah, do the original. So if we would have done that one, what would have happened in the bottom? We had to have 33 under the radical again, right? And then we'd have to do it again, and then we'd eventually get back to this. But always just do the original so you don't have to worry about doing more rationalizing denominator. Okay? So here's how this one started. Realize what happened here. They give you a fraction for one of the 6. So you draw a picture that matches that. All right? So I drew a right triangle. I put theta down here. If you put theta here, that just moves the 4 down here, right? And the radical 33 goes there. That's all. I like to put it down there. That's just me. Okay? Use Pythagorean to figure out the missing side, and then do our 6 trig functions. Or only had to find 5 more, right? Because they gave us one of them. Does that make sense? That type of problem.
Yeah.
I know.
We're not ready here. Stop talking.
Right? This is the same type. Do we need to do another one like that?
No.
No, just like it, right?
Yeah.
Okay.
Just did that.
Special right triangle.
Oh, I remember doing
Okay.
this. I remember doing this.
If you memorize these two, if we were to go further, if we had more time in the year to go further in trig, if you memorize these 2 triangles, trig is very, very easy. Okay? So, if we make the 2 legs, how do I know that they're exactly the same?
Because they're opposites of the same.
Right, because we got basically an isosceles right triangle, right? Those 2 sides are equal. Okay? It's called a 45, 45, 90. No matter what this side is, that side's exactly the same. Okay? The hypotenuse is always whatever the length of these sides are times the square root of 2. Always. Okay? If we were to do the Pythagorean theorem, if you're given one of these sides, you could use Pythagorean theorem to find the other ones, right? Because you know that, like if that's a 3, you know that one's a 3. And then if you use Pythagorean theorem and simplify, you get 3 radical 2. All right? But you don't need to do that because you're going to memorize this, right?
Bless you.
Thanks.
Okay? So when you got a 30, 60, okay, no, x radical 2 is different from x squared, right? All right. Opposite the 30, we call the short leg. We're going to call that one the x. The hypotenuse in a 30, 60, 90 is always twice as long as the short leg. So that's going to be 2x. Always. So if this side's a 4, that hypotenuse is an 8. Okay? If that's a 10 there, hypotenuse is a 20. If this is a 12 hypotenuse, what's that? 6. Always. Okay? The long leg, the one opposite the 60, is always the short leg times the square root of 3. Okay? So if that's a 6, the short leg, then the long leg, 6 radical 3. Okay? Now what if the long leg was 6? How do I get the short leg? Divide by radical 3. Okay? So memorize those two special triangles, and then they're going to give you some problems that have a 45-degree angle in it or a 30 or 60-degree angle in it. And you got to answer whatever question they're asking. The other two sides, whatever, I don't know. Let's see what kind of questions they're going to ask us. All right? So here's 30. Which one is 8? Adjacent, opposite, or hypotenuse? Hypotenuse. So the short leg, the opposite to 30, is always half as long. Yes. So then x would be 4 times square root of 3. That quick. If you memorize those, you can get that answer that quick. Make sense? Is B on here? There it is. All right. So if this is a 45, 45, that's the hypotenuse. How do I get from the hypotenuse to one of the legs? Divide by radical 2. Good. So 6 divided by radical 2 means I have to do this. And what is 6 divided by 2? 3. So the answer is 3 radical 2. So basically it's half of that times square root of 2 if you go the other way. Okay? If that's a 3 radical 2 there, watch. What are we going to do? If I had this picture and I put the 3 radical 2 here and I put the 45 here, what do you always do to that to get that? Multiply by radical 2, right? What happens when you do radical 2 times radical 2? It turns into 2, and what's 3 times 2? 6. Okay? Making sense?
Yeah.
If you forget, though, on one of these, you could go x squared. This is x squared equals 6 squared, right? You could do that, right? And solve it using Pythagorean. But you don't have to because you're going to memorize those, right? But that's another way to do it if you forget. Does that make sense what I just said?
Yeah.
If you forget this rule here, since it's a 45-45, you know that those are equal, so you could use Pythagorean to figure it out too. All right, so just a little extra there. This one's real easy. If that's a 6, what's this? 6 radical 2. Just go times radical 2.
Thanks, Caleb.
Okay? Now, this is the long leg.
Yep.
So how do I get to the short leg?
Bob, I read it.
Very good, Vince. So then I gotta do this stuff, right? Which is 7 radical 3 over 3, right? How do I get from the short leg to the long leg? Double it, right? All you gotta do is double the 7. Nothing else. So this is 14 radical 3 over 3. Okay? So whenever you double a fraction, you're just doubling that numerator. If there's a radical in it, you don't mess with the radical, just the one out front. The number out front, okay? I think that's it for today. Now I think we can say what, AJ? There you go. Okay?
No, don't.
AJ. AJ, is that a public?
He loves it.